Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Space domain awareness, the comprehensive understanding of the space environment, is crucial for ensuring the safety and sustainability of space operations. The 27th edition of the Novaspace Satellites to be Built and Launched report forecasts that an average of over 3,700 satellites will be launched annually between 2024 and 2033. That's equivalent to 10 satellites per day. Keeping track of all those satellites, and not to mention all of the accumulated space debris in low, medium, and geostationary Earth orbit, is only going to get more complex. Scout Space launched its first in-space products and services in 2021, allowing spacecraft to see and understand the things around them while on orbit. My guest on this edition of the Ex Terra Podcast is Philip Hover-Smoot, who was named CEO of Scout Space in January of this year. Philip, thank you for joining me on the program.
Thanks for having me.
My pleasure. Let's talk a little bit, first of all, about the Scout Space technology and how it enhances satellite autonomy while improving the space domain awareness and strengthening space safety and security.
Yeah, absolutely. So at Scout Space, we're in the business of building the eyes and the brains of modern satellites. But if you really think hard about what the future of space needs, understanding what's there, where it's going, what it's trying to do is really fundamental to absolutely everything for future space architectures. Whether you are doing a deorbiting mission, grapple and refuel mission, whether you're flying a high-value asset up in GEO or transiting to cislunar space, every single one of those mission profiles has at least one or more material touch points to understanding what the space domain looks like, what's there, how safe is it, where is it going. So space domain awareness, from our perspective, is really crucial and fundamental to absolutely everything that we want to go off and go do in space. So when Scout was started, we started as a space sustainability company. And that's certainly still very much core to what it is that we do and how we think about the world and our kind of mindset as we're going off and trying to create real customer solutions for folks today. But at the core, we just don't think there's any future in space without effective space domain awareness, and moreover, the ability to share that awareness timely and effectively and build timely and effective value additive capabilities on top of that data set, right? The data's fine. Doing something with it that people care about, way better.
Well, then let's talk about the core technology behind the optical payload system that you guys have worked on.
Yeah, absolutely. So we have three different product lines on the hardware side. Of course, we also have a very strong focus in software value additive capabilities. We have a comprehensive common software stack that we call Scout Point that helps enable autonomous operations. We've also built some apps and interesting things on that side. But on the hardware side specifically, we've got three main product types. We've got our large, basically our flagship sensor product called Owl. It's a sizable 35, 45 kilogram GEO and cislunar qualified dual axis gimbal telescope. Comes in three different flavors, a 150 millimeter aperture up to a 350 millimeter aperture. And we're designing that specifically to match some US Space Force and national security DRMs, design reference missions. Basically, what do they need to go off and go look at which frequency, at what relative resolution? And we're building specifically to address those needs. Now, there, of course, are some really interesting potential dual use capabilities for Owl, but for the near term, Owl's a national security sensor. That's what we're building it for. That's where it's going to be flying, hopefully as soon as 2026. Additionally, we've got two other flavors of sensors. We've got our middle market sensors that are really designed around some flexible, different configurations to support RPOD and servicing missions. That's everything from kind of small 1U form factor sensors for small cubes, all the way through multimodal 3U sensors that allow for RPOD and kind of classical orbital servicing vehicle, orbital transfer vehicle missions. It's a little bit of a hard family to quantify because, again, this world is so dynamic and kind of evolutionary at this point that it's hard to say, here's the widget that's going to serve it. So again, we've got everything from small, arguably fairly cheap sensors to go off and go provide some baseline level of situational awareness for a small CubeSat operator, all the way up through here's a fairly performant multimodal sensor with IR or SWIR or something in addition to optical to go allow for both the identification and approach and eventual grapple and separation from an object on orbit. And the sensing requirements for those two different things are just wildly different. So it's a little hard to kind of batch them all into the same family, but we're certainly trying to do that because we think it actually makes quite a bit of sense. Additionally, we're in the process of developing really just a fundamentally basic camera. We want to make sure that we have the opportunity to provide a vision capability to literally any operator, right? So we've built integrated or proposed capabilities to go on everything from a lunar rover to or OTV or a space station. We want to have a capability to go on everything. So we've opened up this new facet to go off and go allow for true, simple, basically just vision, not vision plus processing. That is, of course, a point I should have made about both our OWL and our middle market sensors. They all come with very capable processors operating the Scout Point software framework. But we also want to sell cameras. So, we've gone off and spent a lot of time learning what the right tech is, what the right hardware is, testing it, validating it, understanding how to integrate it. And we're going to try to leverage that to go off and go allow for even the kind of really entry level customers to go off and go have a Scout solution for their vision needs as well.
So take us through a kind of an operational scenario. How does this responsive autonomy capability work in a real-time space operation?
Yeah, absolutely. So, again, there's to set the frame here a little bit, right? Space domain awareness and the solutions that we're building really are, 50, 60 different kind of design reference missions, if you will, or on-ops for 50, 60 different quite unique little, snowflake of a company, right? Every single mission is a little bit different. So it's always very hard to talk in generalities for space domain awareness. But when we conceptualize what the autonomy customers are going to be looking for, that comes down. There's probably two good illustrative examples that I can give that kind of show either end of the spectrum here. One would be your classical constellation operator, right? That is out there flying a number of satellites in some preset configuration through congested space. By enabling that and empowering that constellation with a vision plus autonomy capability, i.e. something more than just hey, there's a conjunction that might happen. You might want to take a look at it, but really to say, hey, look, this conjunction might happen because the object that's coming close to you is uncatalogued. And that bolt that flew off the thing that's never been in a catalog is about to hit you. You don't have time to get that data from the ground. Frankly, you can't get it from the ground anyways because the sensors aren't sensitive enough. Can't see it with optical from the ground because they're not sensitive enough. Right. But it's still going to hit you. What do? You have to have the ability to find the object, understand if the object actually poses a threat, and react. So in our mind, if you're flying a constellation, you've invested quite a bit of money into it. You want to protect it. You want to have the ability to know that, despite, yes, you can go pay the Leo Labs of the world a monthly fee to go get conjunction assessments, but there are still other things out there that they can't see that are a threat to the product. We want to enable those operators in the near term, right? And I'm talking about kind of the next couple of years to find, understand, and maneuver around those uncatalogued or cataloged but not accurately tracked objects. That would be a small maneuver, right? So you think about autonomy, we also think about this in a decision-making framework being the be-all and end-all of this, as opposed to kind of traditional autonomy when we think about self-driving cars. So let me unpack that a little bit, right? So if you're designing a car to go be a self-driving vehicle, your problems are the problems we all know they have, right? They occasionally slam into a cyclist, or a grandma crossing the street looks like a tree, and suddenly the software doesn't recognize it as a person, and there's a problem. So that is not necessarily our problem on orbit, right? On orbit, you've got 6 degrees of freedom. Arguably, you can probably move a kilometer in any direction. You're not going to hit much, right? Space is right. The problem is, how do you get trusted data to allow you to make a decision? Once you've made the decision to maneuver, the actual maneuver is pretty straightforward. So we kind of think of autonomy as decision-making. It's not really the actual maneuver part. Frankly, you just turn the propellant on and make sure you're pointing the right direction and move, right? Cool. We'll leave that to other people. We want to make sure that we're providing accurate federated learning capabilities that allow someone to take inputs either from our sensor or other sensors from satellite systems and to make a decision that can be trusted to allow for that small maneuver. And that is how we think about autonomy. Additionally, the kind of flip side of that, so we talked about kind of that was macro constellation level, how to protect your assets. The other side of autonomy, of course, is the classical servicing economy opportunity. And I came from 2 different OTV companies. momentous in spaceflight. We built, the Vigoride and the Sherpas, some of the earliest OTVs. And I've seen firsthand the struggle of trying to understand how these missions can actually be licensed and operated, right? And the idea is sound. The opportunity is sound. But the problem is it's far more complex to go off and go actually safely approach and grapple with an object than you might actually think, right? And if you look at any of the federal government's regulators' reviews of these applications, there are a lot of questions being asked about, hey, how do we know that your algorithm's the right algorithm to do safe standoff and approach, right? So as you're getting closer to things on orbit, of course, the risk of collision goes up, and you don't always have the ability to communicate, right? Like, we don't have functional mesh networks on orbit. Most of these early stage companies don't necessarily have real-time communications. Not that that actually really exists for most people, but really they're talking to their satellite every once in a while, right? And the path is not totally consistent. So when you're getting really close to an object, you have to have a level of autonomy baked into that capability, because you're not always going to be in communication with your satellite. So it has to be able to understand its environment, make decisions on it, and make decisions that are trustable to the point that you can get a very expensive satellite close to another very expensive satellite and make sure they don't hit and create debris. We think that there's a good, standardized, trusted set of autonomy algorithmic capabilities that can be developed that we think will be eventually approved very easily by regulators, that we want to make the industry standard. We don't think it's wise or advisable for the US government or other allied governments to be licensing spacecraft as one-off snowflakes and unicorns every time, right? Sure. A new algorithm every time. That's going to create risk, and risk is going to eventually create a problem. And we frankly can't accept problems at the scale of what those problems might be. So if we want the orbital servicing economy to be what we all want it to be, we have to be able to develop both trusted data about where objects are in relationship to each other over time without losing track, and then make decisions on it in a way that is safe and trustworthy, which again means federated learning. So that's taking a bunch of inputs from a bunch of different sensors and sources and making sense out of it in real time without a human in the loop. So that's really what we're going for on the autonomy front.
So then how much of a role does something like artificial intelligence, or if you want to call it augmented intelligence or machine learning, how much of that is involved in what it is that you're developing?
Yeah, absolutely. So AI and ML solutions and computer vision capabilities are really rife within every single part of what we do. So yeah, and to be fair, not a large, model human being, right? I'm not an engineer. I'm a lawyer. Just happened to run a space company. So probably not the right person to be talking about the complexities of the exact models that are being operated.
Sure.
But, we integrate machine learning upstream for filtration, right? So this is, hey, we've got a sensor. It's producing a huge amount of data. Most of that data is not going to be helpful for us. So how do we filter that data? That's a machine learning problem. That's a tool and a filter that we've developed to go off and go create basically a more efficient processing model. So we, again, the majority of our sensors have processors integrated. We want to be as least impactful to our hosts as possible. So we need the ability to process our own data, but we of course have every reason to have the, we don't want to over processor ourselves. So we want to filter out the stuff we don't care about and then scale the processor capabilities to make sure that we're able to do the mission we need to go do. So there's machine learning, upstream filtration. Additionally, computer vision from a segmentation and intent estimation perspective is very important. There are some very interesting models that we've developed on the AI side to go off and go enable that. That is the, hey, you're looking at a thing, you kind of think you know what it is. It looks kind of like this other thing, but no one's actually seen it from this angle before. How do you actually make a decision about what the thing is or what it's trying to do or what its capabilities are? So that's another kind of facet there as well. And then eventually, of course, this federated learning problem, which is actually quite interesting and extraordinarily complex. Right. I understand that's actually a very common problem that a number of kind of industrial AI and ML applications are trying to figure out in different contexts that we also need to figure out on orbit, which of course is just way more complicated to do in space than it is when you're running an oil refinery. But that is also part of where AI will come in, right? How do you assign different levels of trust based on different parameters, dynamically changing parameters to make sure that you're making the best possible decision based on the data that's available. And that's a very, very important point, that federated learning problem that needs to be autonomously and intelligently able to adapt to dynamic environments is, again, exactly where we're going. And this is a bit of a struggle for, I think, people when they're trying to wrap their minds around the SDA world and autonomy, because we're not there yet, right? But very soon we'll be at the point where we have thousands and tens of thousands of satellites with propulsion, dynamically maneuvering on orbit. And we have an existing infrastructure that only looks at these things every once in a while. And when you think about one object moving, that's scary enough, right? If you follow any of the people tracking SDA on social media, you'll have, notifications about orbital maneuver changes. Yes, we pick them up hours or days after they happen. And that's for a single object, right? When we're talking about dozens and then hundreds and then thousands of these things happening simultaneously, but you're only looking at them every couple hours or every day or two, it doesn't work. It just fundamentally doesn't work. So these things have to be solved, and you have to figure out how to assign different levels of fidelity to different data sets enabled to make it happen. And how to do that in a way that's regulatorily approvable is just extremely difficult.
I want to shift gears a little bit, Philip, and talk about your work with Dawn Aerospace. What is significant about that little partnership?
Yeah, absolutely. So our partnership with Dawn is near and dear to my heart because it was my concept. It's like my baby. I think when we started thinking about what VLEO presents by way of a problem set to our customers, right? And right now we're 99.9% focused on the Department of Defense, U.S. Space Force, and intelligence community. That is who we care about, right? So we're trying to make sure that space can be monitored to allow for secure operations and maneuver for us and our allies, right? VLEO presents some really interesting challenges, right? So, and, of course, any one of us only has a limited understanding of what the US government's capabilities are for good reason. But what I understand is that we are currently today operating a combination of both ground-based and in-orbit-based sensors to figure out where things are and what they're trying to do. Those sensors are uniquely poorly positioned to handle VLEO issues. Let me explain. So when you're closer to the Earth, you're moving faster. Your windows of observation from ground-based sensors are smaller, right? So you basically are a faster moving object, maybe more frequently, but for shorter periods of time. So there's some fundamental physics around the limitations of ground-based sensors to look at things in VLEO. It just makes it a little bit harder. Admittedly, those ground-based sensors, optics, lasers, what have you, are actually fairly effective, right? Especially when you're closer, you're 300 kilometers away, you can see things better than you can when they're 1,000 kilometers away. It's common sense. But still, it's imperfect, right? If you look at where these sensors are located and the fans and arcs of where they can actually kind of orient to look, it is limited. There are gaps. We understand there are gaps. We know our adversaries maneuver in those gaps. There's no reason to believe they wouldn't maneuver in those gaps in VLEO because they're doing it in LEO and elsewhere. Why wouldn't they do it there as well? So there's a problem there. And for SDA operators, it's extremely important not to lose track of things. This is something we've had a number of contracts working with Space Force on. Understanding how to hand off track from sensor to sensor is actually very, very difficult technically. And if you lose track of something, it can be hours or days before you find it again. Again, that doesn't work when you're talking about the future economies of scale. So orbit to orbit, NEI imaging, non-Earth imaging, basically RSOs, resident space objects being looked at by a sensor on orbit. Actually, from an optical perspective, it's very, very hard to look at things pointing down towards the Earth, right? In a world, I operate things on orbit. I want them to look at a shiny object with a black background. That gives me the best possible resolution. It means I can see the most detail. It's easiest to segment. It just makes it for clean imaging. If you're in LEO and you're looking down into VLEO, more likely than not, some exceptions about, maybe you can catch something kind of like around the edge of the Earth and the land, or whatever, but more likely than not, you're looking at an object that is scattered with Earth light, right? Sure. So you're actually going to struggle to do a lot of the processing and kind of, data value additive things that you need to do to have meaningful SDA instead of just like, oh, there's an object right there, right? That's less useful than making it actionable intelligence out of it. So you want to be able to have a clean image. Well, as I said, you can't really do it from the ground all that well because your opportunities are limited. You can't really do it from above because you're looking down, you're going to have all this backscatter and backlight. So how can you just get higher, right? And fundamentally, the Dawn Mark II suborbital craft is just a really interesting demonstrator opportunity for us to go and look at what it would take to put sensors in the fuselage of the aircraft, cut out the top of the fuselage, put in a kind of a proprietary optical window, and then mount a number of sensors inside. So we're flying 2 different cameras, actually probably 3 different cameras of 2 different types on our concept of operations or our kind of demonstration mission to go off and go think about what this would be. And we think there's a really interesting niche there, not just because VLEO is an emerging kind of threat environment, not just because Russia and China are actively putting things up in VLEO, most of the time observation platforms, because of obvious reasons. It's easier to see things when you're closer. But because there's no other solutions out there. There isn't another solution. And moreover, these solutions that are out there are extremely expensive. VLEOs, you got to go to LEO first and then work your way down. So you need effective prop. By the time you get there, you have to have a very effective prop system and a lot of prop itself to go off and go persist there. Otherwise, you just get dragged back to the Earth. So it's a hard operating environment. By using a reusable, taskable, fly from anywhere platform, we don't have to build an expensive spacecraft with a capable propellant system and launch it and then deorbit it. Like we can literally throw one of these in the back of a C-17, fly it to an atoll anywhere in the middle of the, pick an ocean, and we're on orbit a couple hours later. The mission profiles are short, right? It's 45 minutes. Right. Wait for the thing to fly over. You fly up, you take some pictures, you land. I get my sensor back. Dawn gets their airplane back. It's a classic reusability thing, right? Otherwise, anything you fly up into VLEO is going to burn the hell up. My sensors don't burn up. I get it back, right? So I only need to build a couple of these things. So the economics, the price point is just really, truly phenomenal. So in my mind, this is a really elegant solution because not only am I solving a problem that's uniquely difficult for SDA operators in VLEO, but I'm also doing it in a way that arguably is going to be like factors cheaper and dynamically. Sure. When you throw something in VLEO, you're in one plane in one place, right? Yes, you can maneuver around. Like it's very expensive and time consuming. I can build and I can put 3 of these things on 3 continents and fly them. And the price point is a tiny fraction of what one satellite in VLEO would actually look like. And I can be right up close and personal with these things in the future on kind of, future variants of this that you just can't ever possibly achieve it anywhere near the same price point. So solving a problem that's an emergent problem that people really very much do care about. And I'm doing it at a price point by leveraging reusability that no one can touch. It's just an absolutely beautiful solution.
My guest is Philip Hover-Smoot, CEO of Scout Space on the Ex Terra Podcast. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Let's talk about you for just a minute, Philip. You said you're a lawyer, you're not an engineer, you're not a rocket scientist. How did you get involved in the space industry?
Oh, that's a great story. Well, it's not a great story. But yes, I am a lawyer. I'm not a space guy. I'm not a traditional space guy at all. Actually, I don't have any kind of messianic space, ideology that a lot of people do in this industry. And it's impressive for those that have it. I just don't. I wanted to be a fighter pilot when I was a kid, and I wanted to get into aviation after law school. And honestly, I didn't really know how to do it. So I started doing a number of roles initially in kind of like air cargo operations and eventually into international trade. That led directly to working at my first aerospace defense company. It's a small entity now owned by TransDigm, a big entity in A&D. Went from there to a couple of roles at Raytheon, primarily supporting aircraft platforms, right? So I was 4th and 5th gen sensors and electronic warfare capabilities, primarily on the international side, right? So, FMS, DCS cases for weapon sales. I did that for a number of years, ended up eventually, I'm from the Bay Area originally. Mm-hmm. So, my entire life is basically here. I was down in Southern California most of my time at Raytheon, and an opportunity to come back to the Bay Area to join a small startup in the space industry came up, and that was Momentous. So I joined Momentous as in-house counsel supporting regulatory matters. Mm-hmm. Helped take them effectively from really like not really any employees at all the way through being a $1.2 billion company, and then we went public and it went all totally sideways. They're still somehow surviving. Not totally sure how that's happened, but that was an interesting experience. Of course, there's a long history with that company and a lot of the challenges that occurred, some of which are still kind of a hangover for a lot of us today. There's a trial coming up in February. Fun times. So, in retrospect, probably should have just cut and run back to aviation world at that point. But moved from Momentous to spaceflight as general counsel. Was general counsel at spaceflight for a while. Again, OTVs, launch aggregation. Launched a lot of rockets, flew a lot of satellites, built a bunch of OTVs. Fun times. Eventually helped handle the sale of that company to AE Industrial's Portco called Firefly. Exited as part of that transition, as people do in PE acquisitions, and then went to Scout as general counsel. I was general counsel, though, as kind of a follow-on, right? So I had actually been working with the Scout guys for about 18 months prior to joining full time as an outside counsel advisor, eventually as an investor. And I took a board seat as part of their seed round. So when I came on board as a general counsel, that was a very natural thing, right? I'd been around the team for a long time. I was already on the board. It was very natural. And then, of course, took over in January as part of the, kind of 5 years in leadership transition that we went through. So again, I'm just a non-traditional person. It's just, I don't know. I'm probably the least normal background of any space person running a space company at this point. But yeah. But
that gives you an interesting perspective from my point of view. It seems like that it would give you an opportunity to bring kind of a different look at things, as opposed to as someone who's been entrenched in the space industry for years and years and years. You've got a fresh outlook on things.
Yeah, I'd like to think so, right? I mean, and at Scout, we've taken a very intentional approach to how to kind of drive innovation and kind of be open to ideas. In fact, I was just out in DC for an all hands last week, and part of the all hands was an internal pitch comp, right? It was any idea, however situated for whatever technology, like what can we do? Right? What's interesting? I mean, the fact that we're flying the space plane, right? That was a non-technical CEO's idea of like, hey, like, what if we took this thing over here and put it with this thing over there? Like, couldn't it be cool? And it is actually very interesting. We've developed some very, very interesting IP around how to integrate, space qualified sensors into a aircraft platform that frankly hadn't solved before. So, I like to think so, right? I'm a little bit intellectually peripatetic, right? I did, a JD, and I didn't want to be a lawyer, so I did an MBA. I finished that. I did a postdoctoral brief stint at Stanford Spokane in international security. I worked on an LLM in maritime law at UCL London. I did a PhD briefly at Embry-Riddle in aerospace defense, mergers and acquisitions activity, neither of which I finished, to be clear. But I've always been just kind of like all over the map about what can be next, and I think there's a healthy level of that, right? That is, I think, one of those things that has kind of allowed me to integrate well into startup world, because there's a lot of this kind of churny, like, oh my gosh, everything's different every 3 months and you need to be able to survive. But it is also, I think, it does help to provide a diverse perspective that probably annoys the hell out of my engineers, but
sometimes engineers need to be annoyed. So then, Philip, from that perspective, what kind of role do you see for private companies in the evolving space sector? It's always been a government thing, and now it's not so much. How do you see that role?
Yeah, well, so that's actually an interesting premise, right? So I don't totally agree that it's always been a government thing and now not so much. Space has always been a warfighting domain, and space will always be a warfighting domain. I think, I don't know, you can't see it, but I got a peace sign on the wall back there, right? I live in Santa Cruz, California. I'm about as hippie as anyone in the defense industry gets.
Hey, look at my hair.
Fair. But, so while I don't hope for conflict, and frankly, I think if you read any of one of my earliest op-eds was about how space domain awareness can be an effective deterrent to future conflict, right? And I think that's actually real. That wasn't just fluff. There's a good deterrent capability for what we build. We're also sanguine to the reality that there may be conflict, and it may be in the near term, right? I think everyone understands that in 2026, we're looking at a significantly increased risk of conflict with China. We don't necessarily want that to happen, but we also need to be realistic that in great power conflict, the first thing that will happen will be someone's going to take out the satellites. It's inevitable. I think there's very few people, I would imagine, again, not a war gamer, but I know people do that. I would bet most of the time, a lot of these things involve conflict starting at least very early in orbit, right? So it's part of the reason why we're building proliferated capabilities, right? So, I mean, our OWL sensor is being built specifically because we want to have 6 to 12 of these things up there because, the existing on-orbit government capabilities are going to get taken out in minute 6. Most of our capabilities are going to get taken out in minute 12. And by minute 15, our hope is 2 or 3 or 4 or 5 of our sensors are still alive. We want to have that persistent capability. So I do find it interesting, and having come from a couple companies that, of course, are kind of have been bet completely on this commercial adaptation of the orbital environment to purely capitalist purposes. It is interesting to me that we're all so focused on that, because it is a very hard thing to understand that all of these business models are dependent upon coming in second to the reality of national security space operations, right? Like every license you get goes through a national security interagency review. If they don't like what you're doing, you don't get to fly. if there's conflict on orbit, we're all hosed. If there's conflict on orbit, there's also basically, preparations to second commercial operators into a government operating framework, right? And while I think that's actually good public policy, and we're actively involved in trying to help facilitate that and participate in that, we shouldn't pretend like that's not the reality of it, right? Like it is it's like operating a McDonald's, in Basra, right? Like, yeah, cool. Like you're operating a McDonald's in Basra, but the reality is you're in a protected area behind a fence, protected by government people, and you're only there because the government's let you be there. Technically you're a restaurant, technically you're commercial, but the reality is you're not. So again, I'm not trying to problematize the premise, right? I think I made that point, right? But it is interesting to think about how we all adapt to it. And, I think those companies that will survive will be those that understand that the needs of space operators will change as an increase in commercial operations are tolerated. So today we're 99% US government focused, and that's because that's where the people who care about our technologies are. We do, as you've heard, believe that as we move forward, future commercial architectures cannot exist without effective space domain awareness operating at the edge with autonomy baked into it. But we're not there yet, right? So we are also very realistic about that. And we want to make sure that we're doing everything we can to go off and go build those capabilities for tomorrow, while also having a defensible, viable, profitable business today. So I think there's some healthy optimism, but there's a little bit too much bullish, commercial future. Is it has to be intrinsically part government, part commercial. Anyone who's purely commercial at this point is missing the boat, and they're going to get burned. That's maybe too pessimistic of me, but.
Let's. You mentioned your first editorial, but I want to come back to one that's a little bit more recent that you wrote in Space News, and you said the space industry of the modern context demands honest introspection. What did you mean by that?
Yeah, I think there is a very strong incentive in startup world, in VC-backed world, to basically pitch optimism until your eyes bleed, and I think that's not necessarily healthy. I think there is a real opportunity in space, but to truly capture it, you have to be a bit realistic. It's not to say that you shouldn't take risks. It's not to say you shouldn't push the envelope. Far from it. I think there needs to be more of that, but it needs to be couched in realistic terms. Again, I've got the scars and the gray hairs to kind of show what happens when companies in the space industry have overhyped expectations of what the world will look like. And I just don't think it's healthy. I don't think it's not good for us. It's not good for the entities that deserve funding to struggle to get funding because those that came before us overpromised and underdelivered. I think there needs to be a realization that we are largely regurgitating old tech. We are guilty of this as well, right? We are building space domain awareness capabilities when the first space domain awareness capabilities were started back in the 1960s, right? It's not new. And there are some really fascinating businesses out there that are taking truly novel approaches at things, right? Interloon is out there, trying to figure out how to mine helium-3 on the moon. That is a great example of something that is a highly specific niche bet. It's high risk, high exposure, but high reward. Those are the kinds of things that need to be rewarded and incentivized. But it's very hard today to go out and go raise money without basically everyone pivoting eventually to being a fully integrated bus operator, right? And I see this almost every couple of weeks where a company that's building a specific capability is suddenly building an all-up spacecraft bus because their investors think that that's the only way they're going to go capture market share. But the reality is there's 40 to 60 companies out there building buses and OTVs right now, not a single one of which will ever be able to hit their estimates of potential revenue because there's just not enough customers to go and buy these things, right? So I think, to be fair, that's capitalism. That's the way the world's supposed to work, right? Maybe capital gets allocated inefficiently. Maybe those companies should die. The vast majority of them should die, and that's a healthy thing. But I think we need to be realistic about the complexity of what we're building, why we're building it, and focus on the harder problems and stop funding things that don't have closable business models that are just largely recreating government tech from decades ago at a commercial price point for customers that may or may not care.
I'm old enough that I was around the aviation industry for a long time as well. And there have been a lot of companies that have sold a lot of vapor planes. And then I lived through the dot-com thing, and there was a lot of vaporware that was out there that never went anywhere. Are we in the same spot right now with the commercial space industry?
So I think the space industry is overhyped in the near term and underhyped in the long term. So I don't think we're in a 2008 housing or 2001.com kind of a bubble, because there just really wasn't an underlying asset class that was of interest. Here, there is real bloody opportunity, right? The few people who can figure out how to build good, stable, helpful hardware iteratively, and they're going to do wonderfully, right? I mean, I think of this as like the Wild West, right? I mean, like I've got my great grandfather, yeah, was a wildcatter. I've got his picture on my desk right here. He's like my entrepreneurial spirit animal, and like he basically traveled the West, like drilling wells, 120 years ago, and 99% of the wells he drilled were just dry, right? And he got chased out of town. And then some weren't, and that changed my life, and that's extraordinary, right? And I think that's the same model and ethos that we can all take into the space industry today. There is real bloody opportunity. You just need to go drill the right holes in the right place at the right time, and for the few that do, it's going to be extremely remunerative. But there's going to be a lot of people selling snake oil and kind of doing things they shouldn't be doing.
It cures hoarseness. Philip, we are just about out of time. It's an old reference to a W.C. Fields movie that you may have never seen. Well, we are just about out of time, but we ask this of all of our guests on the Ex Terra podcast, and that's to look out over the next 10 to 15 years in the commercial space industry and the role that Scout Space is going to play in it. And tell me what you see.
Yeah, I'm very much fascinated in what we can build on the autonomy front. Not to say that I am dismissive of or unappreciative of the investments that our U.S. government customers are making into space domain awareness. I think that's a given, and frankly, we are privileged to be able to support it. But when I think forward about what we can do to really solve our customers' problems on the commercial front, autonomy is where it's at. I regularly tell this kind of vignette about the Earth observation operators a decade ago, where there's kind of the first bow wave of these people who came out and they raised a bunch of money and they flew some satellites and they started producing all this data, and they're trying to just sell terabytes of data to people. And everyone's like, oh my God, we just don't want your data anymore. Like, cool. Like, no more pictures. We want analytics, right? And it very quickly became clear that, and a lot of companies died as a result, that these EO companies providing just imagery, just data, it wasn't enough, right? You have to do something with it. And we really think there's an amazing opportunity for what we can add with our data layer as the base, right? What can we build on top of it? Which is why we bought a small software company last year to go accelerate our autonomy capabilities. It is the one thing that can enable the true, nerd hackles on the back of the neck getting, on end, because you can go and build these mega constellations and mega structures and all these things that, we all want to see happen. That, to be fair, a lot of them might be pushed out further than 10, 15 years. But the capabilities we're building today are the one thing that can directly enable that, right? You can pick a different prop system any day of the week. You can pick a different OPC any day of the week. Again, 50, 60 different OTV bus operators out there. It's all kind of interchangeable. The one immutable reality is you have to have effective domain awareness and autonomy capabilities to ever grow and scale in space. Without it, it just doesn't work, and it's all going to end in catastrophe. So for me, that one is a really interesting trend because we're well positioned to capitalize on it. And two, it's also really bloody scary, right? Because if we don't appropriately invest in it, this is existential stuff, right? This is like, if we don't do this well, we will end up in a position with real dangerous real world impacts. And we want to do everything we can to build capabilities to go stop that from happening.
Philip, I had a lot more, but I'm out of time, but I really appreciate you taking time to talk with me today. It's been very interesting.
Yeah, absolutely. Thank you for the time, Tom.
Philip Hover-Smoot is the CEO of Scout Space. And that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Audible, and many other popular podcasting platforms. Be sure to click subscribe so you don't miss any of our podcasts. or any of our other videos. You can get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on X at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers like Galileo through his looking glass. Thirst for reason, a dreamer's eyes we gaze into. A sense of purpose, know my view.